For years, the world got comfortable with a lie, a convenient, quiet lie, that India, a nation of 1.4 billion people, a civilization older than most countries on Earth, could build talent but not power, that it could produce engineers but never dominance, that it would always buy, never create, always follow, never lead. And for a long time, that story wasn't entirely wrong. But while the world kept repeating it, India was doing something far more dangerous. It was learning, quietly, patiently, ruthlessly, not chasing headlines, not asking for permission, just building. And now the same countries that once armed India are watching it outgrow them. Because this isn't just about progress anymore. This is about power. In this video, we're breaking down 6 new super weapons and technologies that could make India virtually unstoppable. From submarines that never surface, to communication systems that cannot be hacked, to missiles that no defense system on Earth can fully stop. But before we go further, a quick pause. A big thank you to our channel members. Your support truly means a lot and helps us keep going. If you've been watching our videos and haven't subscribed yet, this is your sign. It genuinely helps us grow, and it allows us to keep telling stories like this. All right, now let's begin. Let's talk about the real state of the Indian Ocean right now, because it is not the peaceful body of water that most people imagine when they look at a map. The Indian Ocean is a battlefield in slow motion. China has 78 operational submarines. India has 19. Pakistan is in the process of receiving 8 brand new, state-of-the-art submarines directly from China in a deal worth $5 billion. $5 billion. That is the kind of money that buys you a Navy presence that can threaten shipping lanes, that can creep toward coastlines, that can lurk in the deep water and watch everything that moves. India sees all of this. India has been watching this naval expansion for years. And the answer India has come up with is not to panic. It is not to simply buy more old submarines and call it a day. The answer is to fundamentally change what a submarine is capable of doing. Here is the problem with most of India's current submarine fleet. Most of these vessels, and they are aging, they are nearing the end of their operational lives, have a critical vulnerability. Every 2 to 3 days, they have to surface. They have to come up to recharge their batteries. And in those moments, they are exposed. A satellite can spot them. A radar can lock onto them. In a real conflict, that window of exposure could be fatal. So the question being asked in India's defense corridors is simple. What if a submarine never had to surface at all? That is the question that Project 75 India is answering. In August of 2025, India finalized a deal worth 70,000 crore rupees with ThyssenKrupp Marine Systems of Germany. The contract is for 6 next-generation submarines, not ordinary diesel-electric submarines, not upgraded versions of existing vessels. These are submarines equipped with Air Independent Propulsion technology, AIP, a system that allows a submarine to generate its own power without ever needing to breathe outside air. Think about what that means for a moment. Instead of surfacing every few days, these submarines can stay submerged for 2 to 3 continuous weeks. They generate electricity through stored fuel and liquid oxygen. No atmospheric air required, no exposure, no vulnerability, just silence and depth. But here's what makes this even more remarkable. India is not simply buying these submarines and leaving it at that. The deal includes a full transfer of technology. German engineers will work alongside Indian engineers. Indian shipyards will absorb this knowledge, this process, this capability. By the time the 6th submarine rolls out, India will know exactly how to build these vessels entirely on its own. And simultaneously, because India is not waiting, DRDO, India's own defense research organization, is developing an indigenous AIP system that will be retrofitted onto the 6 existing submarines already in service. So the fleet India has right now gets an upgrade. And the fleet India is building will be even more advanced from the start. The first submarine under Project 75 India is expected to be ready by 2032. That is not far away. And when it slides silently beneath the surface of the Indian Ocean for the first time, China and Pakistan will know that the calculus in those waters has permanently changed. In naval warfare, The submarine you cannot find is the submarine you cannot fight. India just started building submarines that cannot be found. Right now, at this very moment, there are rooms full of highly trained intelligence operatives in countries surrounding India who are doing one thing: trying to intercept military communications, trying to steal information, troop movements, missile coordinates, battle plans, command structures, and they are good at it. Military encryption has been the standard defense against this kind of threat for decades. When a commander sends a message on an encrypted channel, that message is scrambled into something completely unintelligible. The idea is that even if an enemy intercepts the message, they cannot read it because they do not have the key to decode it. But here is the uncomfortable truth that most people do not want to sit with. Encryption is not impenetrable. It is not a wall that can never be broken. It is a mathematical puzzle. And mathematical puzzles, given enough time and enough computing power, can be solved. Right now, adversary nations can intercept an encrypted military message, copy it, and store it. They do not need to break it immediately. They can hold on to it, wait, and as computing technology improves, as quantum computers become more powerful, they can crack open those old messages and read everything that was inside. That is not a hypothetical threat. That is a real, active, ongoing vulnerability. Pakistan has sophisticated cyber intelligence units. China has some of the most advanced state-sponsored hacking operations on the planet. They are not sitting still. They are constantly probing, intercepting, and storing. But in June of 2025, India demonstrated something that changes this entire equation. On June 16, 2025, researchers from DRDO and the Indian Institute of Technology in Delhi successfully tested a quantum key distribution system, and the implications of what they proved that day are staggering. Forget conventional encryption, forget mathematical codes and scrambled messages. Quantum key distribution does not send a coded message. It sends quantum light particles, individual photons, particles of light that carry information at the subatomic level. And these particles behave in a way that is fundamentally unlike anything in the classical world of computing and cryptography. If anyone tries to intercept these particles, even just to observe them, even just to look, the particles change. The act of observation itself alters them. Both the sender and the receiver are immediately alerted. The hacker does not get the message. The hacker does not even get a corrupted version of the message. The hacker gets nothing. And the legitimate parties know instantly that someone tried. This is not a clever trick of mathematics. This is physics. The laws of the universe themselves are working as the security system. Think about what that means. No matter how powerful China's computers become, no matter how sophisticated Pakistan's cyber units grow, no matter what technology emerges in the next 50 years, they cannot break a system that is protected not by code, but by the fundamental behavior of subatomic particles. On that June day in 2025, DRDO and IIT Delhi transmitted a quantum message over 1 kilometer. The test worked exactly as the science predicted it would. Every attempted interception was flagged instantly. The next steps are already being planned. The Center for Development of Advanced Computing, CDAC, is building a mobile version of this system that can be deployed in active war zones, on moving vehicles, in field conditions where reliability and speed are matters of life and death. And the long-term vision? A satellite-based quantum communication network covering the entire country of India, a web of unhackable, physically unbreakable communication spanning every corner of the subcontinent. When that network exists, India's military commanders will be able to speak freely, knowing with absolute certainty that no one is listening, that no one can listen, that the laws of physics themselves are standing guard. In modern warfare, information is the most valuable weapon. India just built a vault that cannot be opened. There is a club in this world, no applications, no ceremonies. The only way to join is to do something only the most powerful nations on Earth have ever managed. Until March 2024, that club had 6 members: the United States, Russia, China, France, the United Kingdom. And one more the world had quietly agreed would never make it. On March 11, 2024, India kicked the door open. The technology is called MIRV, Multiple Independently Targetable Re-Entry Vehicle. The name is deliberately boring, as if to disguise how terrifying the capability actually is. A traditional ballistic missile is formidable, but it has one limitation. One missile, one warhead, one target. A defense system gets one shot to stop it. A MIRV-capable missile changes everything. It launches looking like any other ballistic missile. Enemy radar tracks it. Defense systems calculate the trajectory. Then, somewhere in the cold silence of space, above the reach of any interceptor, the missile opens and releases not one warhead, but several, each independently programmed, each locked onto a separate target, each descending simultaneously at hypersonic speed. No defense system can track all of them. No interceptor can be in 3 places at once. India tested this with the Agni 5 missile, a weapon with a range exceeding 5,000 kilometers. Enough to reach every major city in China, every installation in Pakistan, every target that matters. The mission was called Divyastra, Sanskrit for divine weapon. The logic of deterrence is brutal but honest. If an adversary knows that attacking India means multiple warheads striking multiple cities with no defense capable of stopping them all, that adversary will not attack. India has joined the most exclusive technological club in the history of human warfare, and the 6 nations already inside know exactly what it means. On April 25, 2025, inside a DRDO facility in Hyderabad, something happened that nobody outside a very small circle of scientists and defense officials was prepared for. A scramjet engine ran continuously for more than 1,000 seconds. 1,000 seconds. 16 minutes and 40 seconds of sustained hypersonic combustion, and a new world record was born. Before going into why that matters so much, let's take a moment to understand what a scramjet engine actually is and why every major military power on Earth has been desperately trying to master it. A conventional jet engine works by compressing incoming air, mixing it with fuel, igniting the mixture, and using the resulting explosion to generate thrust. It is elegant, it is reliable, and it works beautifully, up to a point. At certain extreme speeds, conventional jet engines simply stop working. The physics breaks down. The combustion cannot be sustained. A scramjet, supersonic combustion ramjet, solves this problem in an entirely different way. Instead of compressing air, it uses the vehicle's own enormous speed to force air into the engine at supersonic velocity. The combustion happens while the airflow is still moving faster than the speed of sound, and the result is an engine that does not just work at hypersonic speeds, it thrives there. Hypersonic means faster than Mach 5, 5 times the speed of sound. At these velocities, a missile is not just fast, it is functionally unstoppable. Here is the brutal mathematics of hypersonic warfare. By the time a radar system detects a hypersonic missile, calculates its trajectory, and triggers a defense response, the missile has already arrived. There is no intercept window. There is no second chance. The only defense against a hypersonic weapon is to never let it be launched in the first place. That is why every major military power, the United States, Russia, China, has poured billions of dollars and decades of research into this technology. And that is why sustaining a scramjet engine is so extraordinarily difficult. The engineering challenges are almost incomprehensible. At hypersonic speeds, the surface temperature of a vehicle climbs to thousands of degrees. The structural materials have to withstand heat that would melt most metals. The fuel combustion has to be controlled with extraordinary precision, while everything around it is vibrating, burning, and moving at velocities that compress time itself. Most nations that have attempted sustained scramjet operation have managed seconds. A minute. Perhaps a few minutes in the most advanced tests. India ran for over 16 minutes, and here is the detail that deserves to be shouted from rooftops across the world. This engine was not the product of foreign collaboration. It was not built using transferred technology from Russia or America or anyone else. Indian scientists and engineers at DRDO designed this engine. Indian hands built it. Indian minds solved the heat management problem, the fuel efficiency challenge, the structural integrity puzzle, from scratch. The applications are staggering in scope. The most immediate use is hypersonic missiles, weapons that make every existing air defense system in the world effectively obsolete. A scramjet-powered missile launched from Indian territory could reach Beijing in approximately 20 minutes. It could reach Islamabad in under 5 minutes. And there is no system currently deployed anywhere on Earth that could intercept it reliably. But the implications go far beyond warfare. DRDO is already working on applying this same technology to reusable space launch vehicles. Right now, getting a satellite into orbit requires a rocket that costs an enormous amount of money to build, launches once, and is then discarded. A scramjet-powered vehicle could take off from a runway like an aircraft, accelerate to hypersonic speed, deliver a payload to orbit, and then return to Earth and land, ready to fly again. The cost of reaching space could drop dramatically. India's already ambitious and impressively cost-efficient space program could become even more extraordinary. And all of it built on an engine that runs on Indian ingenuity, in an Indian laboratory, tested on Indian soil. 16 minutes, a world record, and a message to every other nation watching. India has solved one of the hardest engineering problems in the history of aerospace. Before a soldier ever fires a weapon, before a missile ever leaves its launcher, before a fighter jet ever breaks the sound barrier on its maiden flight. There is a machine that has already run through every possible scenario millions of times. It has calculated the exact path that projectile will take. It has simulated what happens when that missile encounters extreme heat, extreme pressure, extreme velocity. It has modeled every failure mode, every stress fracture, every aerodynamic quirk. And it has done all of this not in days or weeks, but in hours. That machine is a supercomputer. And in 2024, India unveiled one that belongs in the same conversation as the most powerful computing systems on Earth. Its name is Param Rudra. Param Rudra was built by CDAC, the Center for Development of Advanced Computing, the same organization that has been pushing the boundaries of Indian computing power for decades. It runs on Intel Xeon processors and NVIDIA A100 graphics processing units. Its servers, the Rudra servers, are Indian-designed and cooled by advanced liquid cooling systems that keep all that processing power from simply melting under the heat of its own ambition. The number that captures attention is 838 teraflops. That is 838 trillion mathematical calculations every single second. To understand why that number matters in a defense context, think about what modern weapons development actually requires. A nuclear weapon cannot simply be detonated every time a scientist wants to verify that it will work as designed. The global treaties, the environmental consequences, the political fallout, none of it is acceptable. Instead, physicists use supercomputers to simulate nuclear detonations in virtual environments with extraordinary fidelity. They model the behavior of fissile material under extreme conditions, calculate yield, verify trigger mechanisms, and check design integrity, all without touching a single gram of weapons-grade material. The same principle applies to every advanced weapon system. A hypersonic missile's behavior at temperatures exceeding 2,000 degrees cannot be fully captured in a wind tunnel, but it can be simulated on a machine powerful enough to model the physics in real time. The guidance system of a ballistic missile can be tested through millions of simulated flight scenarios before the first physical test ever takes place. A new radar design can be evaluated against hundreds of different threat profiles in a virtual battlespace. Every weapon India is developing, every system described in this story, has been or will be tested first inside a computer like Param Rudra. But the machine's value extends beyond weapons. Weather prediction, climate modeling, disaster forecasting, these capabilities have direct military relevance. Knowing 3 days in advance that a cyclone will change the terrain conditions in a conflict zone. Understanding how monsoon patterns will affect visibility and ground mobility during an operation. These are not abstract questions for military planners. They are the difference between a successful mission and a catastrophe. And here is the strategic dimension that goes beyond the purely technical. Until recently, India was deeply dependent on foreign hardware and foreign data centers for high-performance computing. When the most sensitive calculations happen on machines located in other countries or on machines built by companies headquartered in countries that could become adversaries, there is a vulnerability that no amount of encryption can fully protect against. Param Rudra closes that vulnerability. It keeps India's most sensitive computational work, the simulations, the models, the designs, inside Indian institutions, on Indian machines, under Indian control. The better the computing brain, the more reliable the weapon it helps design. India just built one of the most powerful brains in the world. There is something that runs the entire modern world, not oil, not gold. It is chips and semiconductors. Your phone runs on them. Your car runs on them. Fighter jets, missiles, satellites, drones. Every single one needs chips to work. And for decades, most of the world has gotten these chips from one place: Taiwan. Taiwan makes a huge portion of the world's most advanced chips, and Taiwan sits just 90 miles from China, in waters China considers its own. If China ever moved on Taiwan and disrupted chip production, the global supply would not slow down. It would collapse. Every country that depends on those chips would be in serious trouble. India would be hit hard. Until very recently, India made almost no chips of its own. That is exactly why India started changing things. In 2021, India launched the India Semiconductor mission, committing massive funding to build chip manufacturing at home. The biggest project is a factory being built in Dholera, Gujarat, a partnership between Tata Electronics and Taiwan's power chip. It will produce 50,000 silicon wafers every month. These are not the world's most cutting-edge chips, but they are exactly what India's defense systems, cars, and electronics actually need. And that is just the start. Micron Technology is setting up a facility in India too. Across the whole mission, 10 separate semiconductor projects have been approved. Factories, testing units, design centers, research labs. The entire chain is being built. Why does this matter so much? Right now, if any country decided to stop selling chips to India due to sanctions, politics, or a supply chain crisis, India's weapons programs could stall. Defense systems could go dark. The whole machine could break down. Building chips at home removes that risk permanently. Indian chips made in India, answering to no one else. This is also a transformation of what India is as a country. Chip manufacturing is one of the hardest industries ever created. Building it means training a generation of Indian engineers who understand the most important technology in the world from the inside out. Semiconductors are the new oil. Whoever controls them controls the future. India has finally started drilling on its own land. Take a moment and look at all 6 of these technologies together, not as separate news stories, but as one big plan, a careful, long-term effort to build something India has never really had before: the ability to stand on its own. What does that mean? It means India can build the weapons that protect it, develop the tools that grow its economy, and secure its own future, without needing to ask another country for help, without worrying about whether someone else will sell them what they need. For a long time, India had a problem. Its fighter jets came from Russia and needed Russian mechanics and Russian spare parts to keep flying. Its missiles came from Israel, and Israel could decide at any time to stop selling them. Its radar systems came from America, with American rules attached. These were good relationships. India is not complaining about them, but each one came with a catch, a quiet risk. What happens if that country stops sending spare parts? What if sanctions block the supply? What if their goals and India's goals no longer match? These are not just what-if questions. They are real lessons from history. The 6 technologies in this story are India's way of making sure that never becomes a problem again. A submarine that can hide underwater for weeks, a communication system that cannot be hacked, a missile that can hit several targets at the same time, an engine that can power hypersonic flight, a supercomputer doing trillions of calculations every second, a chip-making industry built right here in India. Each one is an answer. Together they are a complete change, and the world has taken notice. China is paying close attention. America is no longer talking about India as just a buyer of technology, but as a true partner in building it. That is a big shift, and it shows how much India has changed. For 50 years after independence, India worked to build its economy. For the next 50 years, India worked to earn its voice in world affairs. Now, the next fight has begun. The fight to build the most advanced technology in the world on Indian soil, with Indian hands. That fight is already underway, in shipyards, in laboratories, in missile testing ranges, in computing centers, in chip factories going up in Gujarat. This is not something that is coming. This is something that is already here. Thanks for watching. If this video gave you a new way of seeing India's growth, please share it with someone who should see it too. It really helps.